My name is Prakash Subramanian. I have enrolled this AA product management um, course, which is available in Coursera, and I have started with this first module, which is called as a machine learning modeling, and it is pretty interesting. So, in this presentation, I would like to showcase how one can decide a particular machine learning model based on the data given. Um, the project which has been given to us, it's quite interesting. So we have a specific details about this combined cycle power plant, and we need to identify which models is very optimal one based on the analysis I have done personally. And so I have taken three different types of models. So let me go through. The first introduction is about what we are trying to do. We are going to build a predictive model that will estimates the PE value, which is nothing but the net hourly electrical energy output, which is available as a CSV file. When we download this CSV file from the case study page, we will get this data. It is more than around some 900 a list of data available. 9,000, sorry, 9,000 data is available. And using that, we need to identify which is the best machine learning model we can use. So what I did is I followed exactly what the tutor has explained, the crisp DM process, and I have started understanding what exactly the requirement, and then what. Then I downloaded the CSV file and then made some changes, made it into table, and understood the data. Then I have removed and then I segregated the testable data, training data, and this variation will enable me to understand more about this data. Then finally, with this data, then I created different types of modeling, which includes linear regression, decision tree, and random forest. These are the three things I taken. And finally, based on this squared sum error and then R square, I have made a conclusion which particular model really looks good. For that, I used Python script, and then I have validated with this data and able to see so many insights out of this particular data. So, with respect to the business understanding, this is a regression problem, and then I taken it. So definitely, logistic will not work. Logistic regression is related to the classification model, hence I didn't take it. So I used linear regression, decision tree, and random forest. So in random forest also I used this hyperparameter tuning X regression is. So what is the metric I have used? This mean squared error and R square score. Based on this, I will decide which is the best machine learning approaches I can do. Then what are the data we have available? There are four columns which has been considered to identify the target variable. Um, I mean, which is nothing but the features. Yeah. So these features, then it ranges from one place to another, and the target values and everything is available in the Excel file or the CSV data. Then what I did is I checked for the missing values. I think there is no missing values. I completely checked, and there is no valuable, no category variables also there. It's not there. And finally, train and test split. Like as I mentioned, it's 80% I use for training and 20% for testing. Then I do this modeling, one with a linear regression, then with a decision tree, then random forest. Um, yeah, so for that I downloaded Visual Code Studio slideshow. Yeah, so for that I use this Visual Studio Code, and then install the Python code, and then and then link this particular CSV file and able to generate this report out of it. So first, when I use the linear regression model, I was able to get the mean squared error as 20.27, and R score was 0.93. And what I understood is it give a good baseline, basically indicating a strong fit of this data. And then I gone into the decision tree. Decision tree is more. I don't know whether this is really a good way of approaching, but I got some good results when I see the mean squared error, which is nearly less than the linear regression model. So it comes to 19.59, and R square is 93.932451. So it shows a slightly better performance than linear regression, but maybe prone to overfitting. That's my conclusion. Then I came to random forest. It's quite interesting, and it took really some time to execute this particular random forest in the Python script. So I have even included the comparison, and then use the best parameter, as you see in the highlighted one. I did the grid search and best parameter selection, trained the model with the best parameters. Looks like this is the best performance with the lowest MSC score and highest R square, indicating it's a very strong fit and generalization. So overall, what I really see is random forest is the best model or approach which we can use for this particular data set. After coming to this conclusion, then what are the features important here? So I mean, I don't know whether this is really too early for me to decide, but somehow I felt this relative humidity, ambience pressure could be not, it might not be required at the highest level. But what is most important thing is the temperature and the exhaust vacuum is something very important data, which serves as input for identifying the prediction of the PE actually. So this is all about my presentation. So let me know or ping me for any questions or answers. Thank you.